Okay, we're going to try another stoichiometry question here. This stoichiometry question involves a mass to mass relationship. And in order to make that relationship, we have to get to moles first because we're always going to be using the mole ratio that we find in the balanced chemical equation. So when we have our balanced chemical equation up here, where we have H2O2 produces H2 and O2. To balance this, we would need two H2O2s and two waters. So I've already pre-set up this table for me, and we'll start with our H2 and our O2. Well, this will be our column for the H2O, and this will be our O2 column. So from our balanced chemical equation, the mole ratio is 2 to 2 to 1, right, based on that mole ratio that we see. And this question says 150.2 grams of hydrogen peroxide is decomposed according to the following reaction. Determine the mass of water produced. So our ultimate goal is to figure out what mass of water we get, and we typically, when we're dealing with mass, we're going to be dealing with the units grams. We're given 150 grams, 150.2 grams of H2O2 to start with, so we'll start there. And in order to relate these two, it's the moles where we do the relationship, right? We have to get to moles. So we know from a mass, we can convert a mass to moles using molar mass. So if we use our periodic table, we can determine the molar mass of H2O2 is going to be 34.02 grams per mole, right? And that's found by adding the masses of two hydrogens and two oxygens together. So once we have that molar mass, we can find moles, right? So our next step after our balanced chemical equation is we're going to find moles. So we're going to find moles of H2O2. Right, so to do that, moles is just mass divided by molar mass. So this would be 150.2 grams divided by 34.02 grams per mole. And you would end up with a number of moles of 4.41504997 moles. So now we know this part. We can now fill in this chart, and I'm going to do that in a different color here. This is 4.415049 moles. You'll notice that I'm not keeping all the digits. Thinking about significant digits at the end, my mass that I started with had 4 significant digits. My molar mass has 4 significant digits. We're doing a bunch of multiplication or division. Our answer should have the same number as the lowest number of significant digits. So if I know that I'm going to be keeping about 4 significant digits when I'm done, as long as I keep a few extra through my calculation, I won't introduce any rounding error. So once we've got our moles of H2O2, now we need to figure out moles of water. And that's where we use the balanced chemical equation, that mole ratio that's found. We know that 4.415 moles of H2O2 has to follow this ratio of 2 to 2 when it's forming water. So we're going to use the mole ratio now. And we are going to solve for moles of water. And a 2 to 2 ratio is the same as a 1 to 1 ratio. But I'm going to write it out so that you can see the steps anyway. So we would take our moles, our 4.415049 moles H2O2, and then we're going to divide by that relationship where that mole ratio is, and that's 2 moles of water. We always want the one we're trying to find on top, dividing by 2 moles H2O2, right? So that brings in our mole ratio. And when we solve for this, we'll get that 4.415049 moles H2O, right? So now we know what this particular number is going to be. We've done that ratio. We know it's going to be 4.415049 moles. And if you understand the idea of ratios and you see that it's 1 to 1, you could also make a statement and just say, since this is a 1 to 1 mole ratio, we would have 4.415049 moles of water. But the key is to show the mole ratio. You have to mention something in your solution about the mole ratio. Okay, that is our check to make sure you're doing it correctly. Our last step then, if we go to solve this problem after we've done our mole ratio, is we want to find the mass, right? We want to find the mass of water. So to do that, to go from moles to mass, we need molar mass. Now the molar mass of water, if you look at your periodic table and add those values up, you're going to get 18.02 grams per mole. So to find mass of H2O, we're just going to do mass equals moles times molar mass. So that is going to be 4.415049 moles times 18.02 grams per mole. And we will get a mass of 79.5592 grams. But when we're looking at our answer in significant digits, we know we need 4 significant digits, so that's going to be 79.56 grams. So that's going to be our answer for our mass of water to the correct number of significant digits. So that's how we solve a mass-to-mass stoichiometry problem. Balanced chemical equation, find moles, mole ratio, and then find our mass. 4 simple steps.